Welcome to Working with Datasets and Chops. A common challenge in working with complex datasets is understanding how to find the data that you're looking for or create smooth transitions between data points. Let's look at a few techniques that we can use for working with datasets and chops. To get started, let's add a pattern chop here into our network, and our pattern chop will act as a stand-in for data that we might want to interact with. Let's go ahead and change this to be a ramp, and let's make one other change here on the channel page and set our extend right behavior to hold. Next, let's add a constant chop here into our network. Finally, we'll add a lookup chop into our network as well. Let's connect our constant to the first input of our lookup and our pattern to the second input of our lookup. Now, the way our lookup behaves is that it allows us to use an index or a normalized index to find values inside of its second input. So for example, in channel 1, as we move from 0 to 1, we'll move across the samples inside of our pattern. Now, for a ramp, this isn't particularly exciting. We see a normal pattern that looks like 0 to 1. But what happens if we change our pattern from something like a ramp to, say, a sine wave? Here, now as we move from 0 to 1, we move through the sine wave. Now, this is interesting and useful for us because we can take advantage of this behavior when we start to think about animation. Let's take a look at what that might look like. Let's begin by adding a timer chop here into our network. And let's add a select chop after our timer. In our select chop, let's go ahead and make sure that we select just the timer fraction channel. Next, let's add a pattern chop to our network. Let's also add a lookup chop. And let's make a few changes. We'll connect the select chop to the first input of our lookup chop, and we'll connect the pattern chop to our second input. In the pattern chop, let's change the name of this channel to be TX. Let's add a null here after our lookup. And let's also add some geometry here into our network. We can add a circle SOP, and we connect the circle SOP to a geometry component. Finally, let's go ahead and make sure that we use this TX channel to drive the translate X parameter for our geometry. Let's make our null one viewer active, grab that TX channel, come up to our geometry component, and drop that as a chop reference on top of our translate X parameter. All right. Now, what will happen when we come back to our timer and start our timer? What we'll see is that we'll use the lookup as we move from the beginning of our timer to the end of our timer. We'll move through this sine wave. Now, this doesn't look too great yet, but let's make some changes. Let's change the radius of our circle down to, say, 0.1 and 0.1. And let's also zoom out ever so slightly here. Let's start our timer again. We can initialize our timer and start it. And now we'll see that we move from 0 to 1 in this back and forth pattern that's defined by our sine wave. Let's make a few other changes to our network. Let's scoot our pattern over. Let's add another pattern chop here into our network. Let's connect our first pattern to our second pattern chop. And let's change its name to TY. So we'll now have a channel in our pattern 3 called TY. Let's head back to the pattern page and change this to a cosine pattern. Let's make a little more room and add a merge chop here into our network. With our merge chop, we can connect both of our pattern chops. And we can then replace just our pattern 2 chop with our newly merged channels. While we're here, let's grab the TY channel and make sure we use that for the translate Y channel or the translate Y parameter on our geometry component. Back on our timer, let's turn down the length to, say, just 5 seconds, reinitialize our timer, and hit start. We'll now see that over the course of 5 seconds, we run through our animation pattern that we've defined here just with chop channels. Now, this is interesting, but we can make a few other changes here as well. Here, back in our pattern, let's go ahead and select both of our pattern chops. On the pattern page, let's turn up the number of cycles to, say, 4, and let's turn the taper from a 1 to 1. Let's change that taper 2 value down to 0. Let's make one other change here on the channel page that set our extend right behavior to hold. This will make sure that when we get to the end of our pattern, we hold here on the last value. Let's head back to our timer, reinitialize it, and hit start again. Now what we'll see is animation that looks like our circle is actually moving in a pattern like it's going down a drain. Now, one of the exciting things about using this type of technique for driving our animation is that we can change the duration without having to change any keyframes. Let's turn the length here of our timer up to 10 and see what happens when we reinitialize and start our timer. Now we use the same animation pattern, but we run through that animation pattern over this new duration of 10 seconds. That's excellent. And in many cases, this is exactly what we might need. And when we're working with normalized ranges, this is a great way for us to think about how to use the lookup chop. But let's think about some other circumstances that we might encounter. Let's start this time by adding a ramp top here to our network. Now we'll make some changes to our ramp top. We can make sure that it's only, in fact, say 10 pixels wide and 1 pixel tall. We can change the color here that start with our first color. And let's make this maybe like a dark red to get started. And here, let's also make some changes so that our second color is maybe more in this like purple range. Excellent. And maybe let's make it just a little more blue. Let's next convert this ramp, say, into chop data because the lookup chop is what we want to use. We can right click on the output of our null, head over to the chop family, grab the top 2 chop, and we've now converted that data into top data. Let's take a look at where the samples are. We can make this viewer active with the A key, use the D key on our keyboard to see the dots to represent each of the samples here inside of our top 2 chop. Let's now take a look at what it means for us to look up a sample inside of our multi-sample chop. Let's start by adding a constant chop here into our network. And let's also go ahead and add a lookup chop as well. Our constant chop is going to go into the first input, and our lookup chop is going to go into the second input. Now, we can use the default setup to find a color as we move from left to right from 0 to 1 to move through that ramp. But if we wanted to know, for example, what the color was for exactly, say, the 6th sample, we need to use a slightly different approach. Here in our lookup chop, let's change our range. So instead of a range of 0 to 1, let's instead look at a range that's going to be defined by the number of samples that are inside of our second input. We can use me.inputs, square brackets, inputs, square brackets. In this case, 1. This is the second index. 0 counts as an index for us. So this is the 0th index input. Here is our first, our 1 index input, and we'll look at the number of samples, num samples, and we'll subtract 1. Excellent. We'll also, while we're here, make sure that we turn off interpolating our samples, and this will give us exactly the value of the sample. So now, as we move by whole indices through what we have here in our top 2 chop, we can see exactly those color values. Now, it might be difficult for us to see it in this format, so let's actually verify a few things for us. Let's also convert this to DATs. So on our top 2, let's right click on the output. Let's head over to the DAT family and select a chop 2. Now, this is a great way for us to find exactly that index so we can verify our results. Let's grab a select DAT. And in our select dat, let's also make sure that we're looking for exactly the same row. So in our rows, we can go by index. Let's go ahead and here in Chan 1, let's make sure that we grab this value as a chop reference. And we're going to grab it for both our start and end row index. Excellent. Here we see 0.686, 686, 0.031, 031, 0.482, 482. We've got a perfect match. Now, why might we use this and why might this be interesting? Well, one way that we might think about doing this is that we might want to say isolate just specific samples inside of a chop. Now, how can we think about using our lookup chop to do something a little more interesting? Well, let's say that we had 2 indices that we wanted to extract values for. Let's go ahead and take our constant chop here. Let's make a copy of it. Let's add a join chop here into our network. And what we'll do is we'll use our constant 2 and constant 3. We'll connect those to the join chop, and this will join those 2 values into one channel, one sample after the other. We'll see here if for our constant 3, we change its value to say maybe 6, that we now have a different value here for our second sample. Let's use this here for the first input of our lookup chop. And we can now see that we're going to have two samples. And these two samples are looking up from our input at the fourth index and the sixth index. If we wanted to see what that looked like, we could then convert it back to top data. Let's go ahead and add a null here in our network. Right click on the output, head over to the top family and use a chop to top. Let's make sure our data format is set to RGBA, and there we have it. We might look at, say, the 0th index. So this is our first color. And now we can find any other sample that goes all the way up to our final index. This is just one of the many ways we can think about using the lookup chop to find a data that's stored inside of chop channels and opens up a world of exciting opportunities and possibilities.